By now, many investors are starting to understand just how transformative and revolutionary humanoid bots, and Tesla's Optimus in particular, will be to humanity. Last year, most were still skeptical, thinking robots are just prototypes, but as soon as later this year, we should see thousands of Tesla bots working in the factories. Our guest today will share why he says Tesla's Optimus is not just a new product, but is a major technological step change, much bigger than personal computers and smartphone revolutions. Tesla is introducing a new paradigm operating system that he calls ActionOS. We have Phil Beisel joining us today. Phil was a founding member of the technical team at Rivian, an electric vehicle maker. He led several key groups, including vehicle UI, mobile, and cloud. Before Rivian, he held various engineering management roles at Apple. Welcome,
Here I
Phil.
am
Thank you
again.
for joining me again.
I'm back.
I appreciate you. Our shows have done
Yeah.
really well. Audience really appreciates your perspective. And this one particular is very interesting. We were talking just before the show that Steve Jobs is somebody that I'm a product manager by heart, by background, and he's somebody that I've looked up to. And you worked at Apple, and now you're deep into Tesla. Thank you very much for sharing this new information.
Yeah, I mean, I think this entire conversation is a bit about perspective, actually. The whole point of where we've come from and how we're arriving at a moment where we'll see the next big product. And it's super exciting, super exciting.
It is exciting, and I don't know if everybody's recognizing it. Certainly, the Tesla investors in the Tesla
No,
retail community
no.
see it, but
Yeah.
majority are missing this. And I like this article that you wrote. You often in your X account at PBEISEL. You guys should check that out. He has all these great articles. This one here, you said the next big thing, and you're going to
Hmm.
share with some of the key points you made here. Why
Yep,
did you
total. Yep.
name it this thing? Yeah, in this way.
I just looked at, I look at technology markets, and I look at sort of where, you know, every, I don't know, give or take 25 years, we have a revolution in some innovation in society that changes society, changes business, changes consumer behavior. And some of these things were pre-tech. Um, maybe the original automobile wouldn't be considered a tech device by today's standards. Uh, when we hit around 1970s, the personal computer, as I would say, the first entry of
Mhm.
technology in people's lives, became a thing. Um, and so, and then we transitioned to kind of and I call that the first compute, in the sense that, this is the first time uh, society as a whole interface with a compute device,
Mhm.
right? Things before that really weren't like that. Um, and then we stepped forward to the mobile phone, which is really a mobile compute device. It took many of the things that we had available in personal computers and put them in our pocket. And then, and that became a real consumer revolution because it merged the telephone, the things that we did on the internet, and this computing device all in one. Um, and I see, as we're leaning forward, that humanoid robotics will be that next big thing. And there's many reasons, and we'll go through them.
I agree with you. This is a huge, moment in time right now. I like this slide that you put together here so well. I think you and I talked earlier, and I told you how Steve Jobs has been my idol for decades
Yeah.
because his approach to creating a product, revolutionizing an area. And yeah, people will say he wasn't the creator of the personal computer. That's true, right? But in many ways he was, and in many ways he drove where it headed towards, and then everyone else copied him. But that was, like you said, the first time we started to actually interact with a computer tech device, and then of course the smartphone. That was a big deal.
Right.
And even when he released the smartphone, wasn't it funny how, like, even then a lot of the community, the folks out there said, it's nothing new. Lots of other people are doing this.
Yeah. Yeah.
It's who everybody still wants to type on a keyboard. This is going to be dead in the water.
Yeah. Steve Jobs was amazing, and I don't. I mean, history will judge him well. Um, people talk about the young Steve Jobs and how mercurial he was and so forth, but it takes a bit of that personality. But he was so incredibly detail oriented in ways that we've lost in many ways, and I think you're right in saying that Steve didn't invent the personal computer. He came along at exactly the right moment, but he sort of made it happen in a
Yeah.
way that Apple was first about the Apple II computer, which I'm not showing in the picture. I'm showing the Mac. The Mac, of course, changed everything, literally changed everything with its user interface. Um, if you think about, like, they're just crazy stories about Steve. One was where he was convincing Bill Atkinson. Bill Atkinson did the quick draw package for that was the low level component in the ROM of the original Mac that did all the drawing primitives. So everything that you see in terms of what would be on a screen, on a graphics screen. And he convinced Bill one afternoon and walked him around outside for hours and convinced him that rounded rectangles
Yes.
were a very important thing. And he was maniacal that way, and he was almost always correct. He was almost always correct. Um, so he had just this incredible focus, and so I do give him, you know, St- Steve Jobs changed my life. He gave me a career, gave me a purpose. Apple II was the first computer I ever touched in my life.
Hmm.
Apple Computer was the first job I ever had in my life. Um, and when I touched that Apple II, I almost knew instantly that I'd be working at Apple.
Hmm.
Um, and the Mac for me changed literally everything. Um, I mean, literally everything. And just for, I want to show you something.
Yeah.
That
Love it.
this,
Yeah.
yeah,
What number
this
is
is
that one?
actually this is
Is that a
actually the
prototype?
Mac. Nope,
Yeah.
real thing. This is
Okay.
the Macintosh SE. Came a little bit later.
Yeah.
Um, a little bit bigger. But boy, this thing's heavy. Black
Yeah.
and white screen. But I mean, it was beautiful. The first day I ever saw a Mac, I walked into a store called Computerland, and that was a store that sold personal computers. There was such a thing back when, and it was filled with IBM PCs,
Yes.
circa 1981 product, and the Mac was released, I think, in '84, January of '84. Um, and I saw it in the corner, and I could see it glowing. And I was just like, oh my God. And I was just, it just kind of grabbed me, took hold, and I started developing on it. And that was when I was still in high school.
Yeah.
And then, yeah, so,
Yeah. So
so anyway.
for you working at Apple and you saw that happening in front of your eyes, now you're seeing it
Mhm.
happen again right in front of our eyes right now. So tell us about
Yeah.
why you put this slide together.
Yeah. Because I'm just trying to, tee up the idea here through computing. We've had kind of like a compute centric approach with the personal computer. We've had a mobile centric compute approach with the smartphone. Both of
Yeah.
these had different user interfaces, um, and ways of interacting with them, but they're mostly their output to us as a screen. They
Yeah.
communicate to us mostly through a screen. And then I said, okay, what is logically next? And to me, if you look at where technology has come, we are just at this moment, and we've reached that tipping point where we can build something, or we, in this case, Tesla and some others, can build something called a humanoid bot, which really pulls a lot of things together. The interface changes to a natural interface, which is basically voice recognition and
Voice.
voice output, right?
Hmm.
Um, and very good comprehension through LM, the LM kind of technology that's happened in AI. Um, and that's like the holy grail, because I don't, if we could do that back in the '70s and the '80s or through the early 2000s with mobile phones, we would have never done. We might have screens, but we would have different ways of manipulating, and as an input device with voice, certainly. And then if you think about what Optimus is it's an opportunity where we finally have component miniaturization, to the point where we can now, like, we can create things that actually create action in the real world,
Mm.
principally through, there's locomotion through its legs, there's action through its hands and arms, much like a human, and we have that coupled with an actual voice interface. And so the reason that I think humanoid bots, and particularly Tesla Optimus, will just go through the roof is that the utility value is so high. If you just think about the utility value, which I talk about later, that is one of the reasons I think it's magic coming,
Hmm.
and we'll have very quick adoption.
Yeah, I agree. I love this. So obviously, you remember Steve's saying, right, that it's like the revolutions happen because of a brand new user interface. How do you
Yeah,
interact with the technology that makes it easy and like powerful for the regular person to do? And he said, well, you had computers, right? You had these massive IBM hardware frames, but you
right.
had to know how to
Inaccessible.
code. You'd have to
Yeah,
have these cards, black and white, and it was just crazy. Now then, he created the GUI, right? Then you kind of point and click with a mouse. Not again, he didn't invent the
right.
mouse, but he recognized it was so critical to change how humans interact with a computer, and that's what happened. With the smartphone, he created that product, but he wouldn't release it, right? He wouldn't release it until the touch interface worked. He
Right.
refused to
Yeah.
keep the keyboard or pen, right? The famous, he said,
Yeah.
the best pen is a
Stylus.
finger. Yeah,
Yep.
no need for a stylus. Like we don't need that.
Yep.
You have the finger.
Yep.
And so this multi-touch approach, and I think that we haven't spoken enough about how voice is actually, like you were just saying now, I agree with you 100%. It's actually the ultimate interface for a human. That's how we interact with each
Yeah.
other,
Until
right?
yeah. Until something changes, say with Neuralink.
Right.
Yeah. Right. No. I mean, seriously.
Brainwaves,
Seriously. Yeah. I mean, and the
right.
fact that we can communicate. I mean, voice isn't very high bandwidth. Um, when you put
Oh,
words
it's
together.
faster than typing. Like I would often say to somebody, "Can we just get
Sure.
on the phone?" Because instead of me typing,
Right.
text, or
Well,
writing little
there's
documents,
there's lots of
talk is
reasons. There's
faster.
more. There's more in it than just the words themselves. Right. There's
Right.
the meaning.
Yeah.
Yeah.
So,
So
so you're,
in this slide,
yeah.
one of the things I wanted to say is I totally agree with your point here is that interface has created the category. It's
Hmm.
one of the reasons I put Mac here and not I didn't reach back to Apple II is because Apple II had sort of a standard interface that people were sort of used to it. I mean, it had graphics, but it was mostly text-based interface. If you remember the IBM PC back in '81, a very important product for the industry, but kind of boring and really didn't revolutionize interface. The Mac, okay, it borrowed from Apple's previous product, Lisa, and Xerox PARC in particular
Hmm.
was the foundation of this graphical user interface. You know, using a mouse for input was crazy. Menus and windows. I mean, who ever thought of such a thing? I mean, Microsoft literally named its product after what Apple revolutionized in this product. And then when you go to the smartphone, again, Herbert, you're completely correct. Is that Steve didn't want a stylus. He rejected Apple's sort of what I'll call, version 1.0 iPhone, which was the Newton, something actually I worked on.
Mm.
He wasn't at Apple at the time. Just as a kind of a demonstration, I have two interesting products here. Okay,
Yeah, yeah.
this one is the Palm Treo. Uh,
Yes.
this is the one where we finally got kind of
Recognition.
a
Yeah.
good size screen,
Yeah.
uh, and but it still had a little teeny keyboard, and it
Yeah.
was a good keyboard. Uh, and my friend Carl did all the hardware on this. So this is a great product
Mm.
actually. But this is the one. This is the iPhone 2007.
Yeah.
And look at it. It's just a sheet of glass. And there's one button on the front, and that's since been removed. So what an incredible change to a different interface. And particularly it isn't just touch; it's multi-touch. It's an important difference because touch would have been just sort of single finger actions, but multi-touch allows you to pinch, Zoom and do all these things with, which is quite incredible. So that's
Yeah.
all the demonstration products I have.
I love
Yeah,
it. Oh God, you don't know. I do have the very first iPhone as well, so and I want to have the very first humanoid bot. I'm sure you do too.
yeah,
I do find it. So we agree that voice is the one of the better. It's a much better interface. And then there's action, though. That's the thing, right? You can say something, and then this item, this product is going to come out and actually do something. So tell me
yeah.
about, decisions by Tesla to do the bot, what it takes for you to roll out a product. I think you had some comments about that. That was interesting.
Yeah, I mean, I think that obsessed with this idea of the tipping point of
Hmm.
technology, like, what it means is that you've reached a place where the technology is mature enough, you can manufacture it at scale, and you can bring it to market. And anybody working on it at the time is probably both satisfied at the thing that they're doing, but dissatisfied that it's not enough.
Hmm.
And I think that's, if you look at the Apple uh, iPhone 2007, it finally reached that point where you could have a device that was on the internet, continuously as a data device. It's really the first time. I mean, Apple, Steve very directly said that he made that special deal with AT&T, and that deal was to give him unlimited data,
Yeah.
so that consumers no longer felt um, that there was a limit, because every previous device the carriers were charging by the byte,
Hmm.
and obviously before that by the call and the minute, and you still heard people use the word long distance call at that
Yeah.
time. So I'm a bit obsessed with this concept of tipping point, and the idea is that with Optimus, Tesla has to get to that point where it thinks it's good enough to put out a version one product uh, in the public domain, manufacture it beyond its walls. I think when they do the first build this year, first substantial build this year, they'll use it themselves, I believe. Maybe maybe they'll sell a few. I don't know, but um, and it's a complex product with a lot of moving parts, literally. Um, and so each of these things will go through a phase of how mature it is. Will, like, for example, in terms of its locomotion, like, the speed at which it can walk and its balance structure, how well it can balance. Can it walk upstairs fluidly? How fluid is it? Right. That'll be an important thing. And then the hands,
Yeah.
you know, how far does that get? Uh, uh, Elon had said in the last earnings call that he wanted it to be in a place where Optimus could play a piano and thread a needle. And, you know, would it be good enough if it couldn't thread a needle in a version one? Would it be good enough in manufacturing industry if it didn't have that kind of dexterity? Probably. Um, so, when you put a product in the market, there's like, obviously Tesla has kind of pre-announced this product to the world. They've told the world they're building it. That's something Apple would never do, right? There is a huge difference between the companies in that regard.
Hmm.
Apple literally never talks about a product um, directly, or even really indirectly, before it's launched, and it's only leaks that create some kind of idea that it's coming. Um, but Elon, I think, has the confidence in this product and knows that and I think he feels that he needs to get the market ready for it as well. I mean, I think it's a really important consideration, is that we've seen these types of humanoid bots in a lot of sci-fi type of movies. We've
Hmm.
seen what a CP3O looks like and what it can do. Um, but it's going to take some time for, like, I think what cements it in adoption is that it will be a business product to start with. It'll be
Hmm.
used in manufacturing, light manufacturing, and service industry, and then people will realize that it's indispensable to home use cases. And in that particular paper that I wrote, I focused almost all exclusively on the consumer.
Consumer.
I
Yeah.
tried, yeah, I kind of jumped past um, that potentially, you know, good territory of business use cases and manufacturing, and just jumped, boom, right into the consumer use cases in the home and as a companion and how it might behave, and what its limits might be as a mobile device, since it's it takes up space a little more than a cell phone.
Yeah, I was going to say that I really do like what you said there. I interviewed Bernd Bornick. He's the
Hmm.
1X Robotics in 1X, and he said that he's positioning their company as going direct to consumer first, because
Hmm.
he said that everything that's actually gone just completely revolutionized a market, it's always been a consumer driven approach. It's just the biggest
Yeah,
use
yeah.
case, the biggest market. So
Uh,
going back to sorry.
no, that's a really interesting question as approach. I mean, look, if you hear Elon speak about the product, he almost always directly ties it to consumer use cases.
And or every human will have one. And if you look
Yeah,
at Tesla's website and you look at the Humanoid bot, it's all consumer home use
right.
cases. So
It's only the rest of us that's kind of pinned it as manufacturing first. To be frank,
yeah,
I mean, if you think about it, analysts, everybody says this is where it's going to go, because what they see is the evolution of robotics, say in factory use cases,
right.
and they see it being a labor tool, driving labor to zero and replacing humans because of its human dexterity and abilities in that zone. Um, and they don't necessarily see the use cases tied to the consumer directly, but Elon always ties it to the consumer. So it's a really interesting high quality problem that Tesla will have
Yeah.
to face, because I think the issue will be that these adoptions. I mean, we all know about how these adoptions happen for any of these technologies. Is that there's a certain group of people that want to have them first, and they get them right as soon as they can. I mean, people stood in line for this thing, big
Yep.
time,
That's me.
right? Yep.
That's you.
Yeah, it was me. And then it cascades into a
Yeah.
longer tail of people that adopt it. And I think the problem with Optimus is it will have so much demand on the business side, and ultimately so much pickup demand on the consumer side, that it'll be probably difficult to build them at scale. The company that builds them at scale is the company that will win, if that has the best product.
Okay. Yeah. So just finalizing the conversation here, um, Elon purposely delayed the kind of production design one of the bot until the hands, specifically the hands. And he just said yesterday that the hands are the most difficult, most intricate, thing ever. More the worse as like a Fabergé, I guess, just really difficult. But they spent a lot of time because the hand is what gets us to what you're calling the action OS, right?
Yeah,
It's the hands that gets you the
right.
most. A lot of smart people are saying that actually people think that locomotion, like the walking, is so cool. And we see these Chinese bot vendors, we see Boston Dynamics, and we're going, look how
Mm.
capable
Right,
they are. They can
right.
flip, they can jump, they can pull themselves up from the ground. All that walking does, it takes you from one place to another place. But the actual activity that actually has tremendous, like actual value to anybody is action,
Yeah.
is your hands. Like it takes you to from one computer to another computer so you can type in the information, right? It takes you
Yeah, in a
from the
sense,
fridge to the stove so that you can cook. But if
right.
really its locomotion can be, it's not as just by walking alone doesn't necessarily give you an action.
Yeah, I no, I totally agree. I mean, it's really the locomotion that gets you to the point where you find the use case that you use the hands, right?
Or
That's
the
what you're
voice.
saying,
Yeah.
or the
Yeah.
voice. Yeah, I mean, and I mean, there will be times when both are important, like carrying things and moving things
Right.
from one point to another.
True.
Um, and the fact is, it will do both. So it's not really an argument, per se. It's not like a trade-off. It's just that I think Elon is saying that he's focused most of the energies and
My
engineering
point
on
being that when
the
Steve
hands.
Jobs launched the smartphone, he was very, very insistent that it had to be the multi-touch user
Right,
interface, the
right,
all
right.
screen.
Right.
And now we're hearing Elon
Yep.
basically saying, I have to have this fully functional hand, not just
Right.
like what other bots have done with the grippers. And they can do work today, but that's not the
Yeah.
revolution. This is
Yeah.
the revolution.
That was my point earlier, to say that it wasn't touch, it was multi-touch.
Yeah.
And that's why it's really there is a huge difference. And you're saying the same thing about the hands. It's that the hands have to reach a certain level of human dexterity to really turn this thing on and make it hit up potential. Because here's the thing about it, is that the expectations will be off the charts in terms of the things it can do, because its presentation is humanoid by definition. And we kind of look at it and what is the thing we're going to compare it to? We're not going to compare it to a smartphone or personal computer. We're going to compare it to another
Yeah.
human.
Yes.
So, humans can do
Yes.
certain things that, they say, well, why can't my robot do what a human can do? And
Yeah.
so I think what Elon has done is he's leaned in on the hand problem. And he's, in a sense, I don't want to say it this way necessarily because I don't know, but in a sense, he's delayed the product. I mean,
Okay.
in a way, that's what I'm getting at about the tipping point, where
Yeah.
the decision framework, he has to reach a point where he says this is good enough for a version one product in the market. And if you jump that line too quickly, then you release, like, imagine that Steve was giving a lot of demos on multi-touch and it just wasn't working right. And he said, okay, good
Mm-hmm.
enough. We'll throw out the just touch interface. Um, and luckily that didn't happen, and didn't happen for him that way. He was able to release multi-touch as a kind of first generation interface. But would the touch interface have, kind of stymied its complete adoption if it didn't have multi-touch? And to a certain extent, yeah, maybe. I mean, if you think about personal computers, I mean, the keyboard's been an important device for entry, but there is no computer that doesn't have a trackpad or mouse today, because that's been a way to directly manipulate the interface. It's all about direct manipulation. And then multi-touch made that um, even more of a direct manipulation. You're literally touching the screen and manipulating, as opposed to using an object to touch the screen by the mouse. And then the bot takes it to the next level, where it's like, okay, you're not touching a screen, you're touching the entire physical world with the product.
That's
So,
pretty cool.
yeah,
Okay. That's tell me how you came up with this slide in ActionOS and 100 times.
well, the the point here is that I was just looking at, like, how incredible the run of we've gone from, like, these very simple CPU based products, which was like the personal computer, and we've run all the way up. I mean, if you look at, like, this comparison here shows where we started and where we're at, where we're almost at with the humanoid
Mm-hmm.
bot. And it's obviously, we're well aware of Moore's law, which is essentially, I mean, technically it's transistor count doubling about every 2 years, but in a sense, it's like all technologies attempting to double their capability every 2 years, and its storage, um,
Yeah.
in terms of CPU power, et cetera. What's interesting about what's happened here is that we started with this idea of these simple operating systems, what I call single program operating systems on, say, personal computers, first personal computers, like the IBM PC or the original Mac. And then as we got towards smartphone age, and certainly with personal computers, we reached multitasking, right? Like, little, a completely different way. And what kind of really got that going was that we took CPUs and we moved them into multi-core. You
Yeah.
could do this in single core, but ultimately multi-core allowed true kind of parallelism. And then when we step up to the humanoid bot, we're changing the OS completely. We're changing from something that is basically a code-based thing to an inference-based thing, right? Where we've trained an AI model. So, if you think about what's going to happen in Optimus, it's much like FSD, very similar. There's a very good tie here, in the sense that it has to perceive the world. It has to create a plan for the little things it's doing. And I've written about that before, but um, all that is done with AI, and the code is really a harness, right? What's running on the CPU is really kind of the orchestration of what has to happen in the GPU or neural cores of the product. And so it really feels very science fiction because we've stepped up to a completely different place from a compute point of view. Um, and so its ultimate outcome is that it is there to uh, sense the world, take commands through voice, and then create actions.
Action
And so
OS. Hmm.
it is an action OS. Yeah. If you go to the next slide, uh, this somebody might want to just look at this at home at some point and just this. I just basically said, where were we when we started with like the Motorola 68,000 processor was the one that was on the Mac, the heavy Mac I picked up had a 68,000 processor in it, and then of course we're at a really good level of compute with, say, Apple today with M3,
M3.
M1, and 3. Yeah, these processors are amazing. Actually, Apple Silicon is really a standout piece of the company. Um, but look what's happened here. You've gone from uh, you know multi-core. You've gone to transistor like the transistor kind of density. Uh, you've dropped power to a certain extent. You've increased speed or reduced latency. And then really what's happened on the Tesla side, which is the last two, the first one, the first column there is the Tesla hardware 4, which is in the current Tesla vehicles,
Hmm.
the ones released now. And then hardware 5, what they call AI 5 is coming. And that's meant to, power Cybercab, future Tesla vehicles, and of course, the same chipset will be an Optimus, and this thing's fire. I mean, if you can look at the trillions of operations per second count in AI performance, uh, that's quite incredible. It's stepping about 10x from a generation,
Hmm.
possibly more.
Hmm.
Depending. I mean, we don't really have perfect specs on these products, um, But but look back to the Motorola day, Motorola 68,000. That was
Yeah.
it. There wasn't even a GPU.
Yeah.
The original Mac just had a frame buffer and it just moved it, to that was how the screen operated. There was no GPU. There was no offloading of drawing the screen. And the GPUs obviously came into play. I don't know what year, but that was a way to to speed up and make screens higher resolution. Um, and now GPUs have been purposed because of essentially the interesting thing. I mean, we know what's happened with the GPU. It's kind of amazing, right? It's that there was a strong recognition that parallelism was key to more compute, and that's why we call it accelerated computing is about parallel operations, but it's the way it's done is I wrote about that as well. It was really a fun subject to tackle because you realize that you couldn't just you couldn't just build CPU, you couldn't just make faster CPUs. We were running into a wall. We were essentially slamming against our heads against. We weren't going to continue with Moore's law by just reducing the transistor or density and increasing the clock rate would not do it because it just wasn't possible. So now we've completely changed the model at which how we do compute, and it's opened up use cases that are tremendous, and that's all AI, right? That's what we do
Hmm.
today. And
Yep.
AI today, AI in neural, AI, the subject matter is kind of a broad space, but we build these things called neural nets, and neural nets do tons and tons of matrix multiplication operations, both on the training side and the inference side. And what you have here in Tesla AA5 is essentially something that it's an inference processor. It's using the model to do the thing. At some point, the next generation will probably allow on-device learning.
Yeah.
where it will actually augment the model
Yeah.
directly. And I've written about
Mm.
that too, and how, we'll get to a place where your Optimus will learn things and then potentially move it back into the fleet,
Yeah.
which is
Hmm.
really, really, really
Yeah.
exciting.
That's
So I
pretty
mean,
cool.
just think of if you drew. I messed around with a graph here to show like the rise of compute, and the only one that ever made sense was the ones that where the axis was always logarithmic,
Yeah.
and you just don't really get the sense of what's going on there, because if you really drew that, it would be like a
It looks
flat
like a line.
line,
Yeah. But it's
and
going
then
to
it
be this.
goes and then it
Yeah.
goes
Yeah.
straight up.
Yeah. Yeah.
Um, but guess what? As per the previous point, without, this is the tipping point. We had to
Yeah.
get here in order to do the things that the robot will have to do. Um,
Yeah.
so it's a convergence of all these little things that make it happen.
I love it. Yeah. Well, I'm glad you pointed this out because obviously the tech had to, there's only a certain point in time in history that this can happen. And only when the tech caught up to what you're asking it to do. And now we're at the exponential jump from everything hardware, CPUs, GPUs, but
Right.
also AI, neural nets, and then, of course, the hardware for the bot, all this,
And
they use it. Yeah.
and the important point to make is that if you're working on Optimus, and you're releasing Optimus to the world, you feel whatever you're putting in there, you're compute constrained. Yeah, I mean, it's you remember
We
this
just
thing that
got
happened.
there. Yeah.
Yeah, but you're still compute constrained.
True.
You don't have enough. I mean, if you think about all the follow-on products that happened with the original Mac and the smartphone, each of them were about adding more compute, and as you or more storage, the whole fabric. But as you did these things, the applications took up that space. And I saw that thing a couple weeks ago, or it was maybe 2 weeks ago, about DeepSeek, and it was a whole NVIDIA scare, and I actually laughed a bit because, well, actually, I got up naively thinking that it would cause a rise in NVIDIA stock because I knew exactly what it meant to the real world. It meant that there was more available compute. Suddenly there was an optimization, at least in the way they approached it, and there was more available compute. But that compute would be taken immediately by engineers want to grab that immediately. So I'm absolutely certain. I mean, look at the issue we have today. Um, Tesla's producing FSD. We're almost at the level. We're almost at unsupervised FSD. We're converging on that rather rapidly. Probably, certainly this year, we'll reach that. We've done a large step
Mm.
change from 11 to 12 was the step change, obviously, because we went from algorithmic planning to AI. Um,
Hmm.
but here we went from a model in 12 that was remarkably small compared to the trained model in 13, right? So the model in 13 is pretty big comparatively, and realistically, there's probably not enough compute on hardware 3 to run that. It's like running a more modern
Right.
application on an
Yeah.
older iPhone,
Yeah.
right? So we've already hit a
That's so
wall
fast.
there.
Yeah.
Yeah, which is crazy because if you
Yeah.
go back over that timeline, right, it's like it's so flat and then it rises, but it's not risen enough. So yeah.
Good. Good. Yeah. So compute, everything's converging. This is it. But this is the most important thing, isn't it? Action-based compute. I like that you called it action-based. I like that it's called ActionOS. That's what you called it. Tell us what this all means.
Yeah, so I just put a handle on it, as Action OS, but
Yeah, I
definitely,
like it.
it's a different way of thinking about the interface through which the product establishes itself. Just like we had graphical user interface, multi-touch. Now we've got something that is action based and interacts with the real world. And what's really interesting is, we have plenty of examples of non-embodied AI in these LLMs and generative AI today. And we even see that being pushed into devices like your cell phone or your
Yeah.
laptop. And that's fine. I mean, they have a lot of utility. Um, but what I think is really the true point where we find this AI incredibly useful is when it goes embodied. And of course, that means that we put the AI in something like an action-based object, like a robot. And of course, one embodied example is FSD in our cars. We think of our cars as four-wheeled robots. But in case of Optimus, it's two legs, two arms, has physical form. And I think it's important to point out that there's some really interesting advantages about embodied, and it means that it does now have physical utility and can perform actions in the real world.
Yeah.
It doesn't statically sit on a desktop and wait for you to talk to it, or in your hand. Um, and why is it, why be human form? Well, we all talk about the fact that if you put it in human form, it interacts very naturally with the world we built for humans, which is completely makes a lot of sense, right? But there's something a little bit more subjective here, perhaps, is the fact that by putting it in human form, we feel it really normalizes our interaction with the product. It allows us to see it to a certain extent like another human, and talk to it and interact with it in a natural
Mhm.
way. That I think it will feel more natural. It certainly, I think you will come to the conclusion that Optimus has a personality versus a smartphone having a personality. Even if you could, and even when as you use, voice with OpenAI or whatever,
Yeah.
you'll feel like it has some personality, but it hasn't developed a personality. And I think you'll see that more with certainly with Optimus.
For
And
sure.
I think the other thing is that what we're going to see in the beginning is that it's a largely a product that does things and isn't a product that's learning right off the bat. And I wrote this whole piece on this idea that it will very, very quickly go into the learning space. It will start learning actions. It'll take commands. It'll start to figure out um, how to do things that it wasn't pre-trained on. And I think that in humanoid form, it will accelerate that because, again, you're talking about an environment that was built for humans. So, and I think the other thing that probably will happen here is that as a general purpose bot, in some cases, it will replace special purpose bots. And it's a subject of it's a bit controversial. People think that there's these expensive, I mean, especially if you look at manufacturing, there's all these special purpose, very expensive robotics today that do certain tasks. Um, but there's a few of them, at least some of them that can be replaced by a humanoid bot, um, which is really exciting. I mean, that's wow, right? So putting this thing in human form has so many advantages. It will make it feel really natural to us.
Yeah, I was
Yeah.
talking to a CEO of a robotics company, and he explained to me that the number one way today to train a bot is through not just simulation, which is obviously what the big way, but
Hmm.
it's also through training, right? Teleoperation. So if a human is holding,
Right.
in set up in
Correct.
gear, and then it picks up a glass of water, a pitcher of water pours into a glass, right? So it's grabbing the glass, it's grabbing the pitcher, it's moving, making that movement, right? If you want to
Right.
train a bot to do that, if you just do it 50 times, then a bot should be able to do it, 85% accuracy. But what they've learned is that the human, maybe they're tall, but the bot is not as tall. Maybe the
Yeah.
human's hands are much longer than the bot's hands are. Maybe the bot doesn't have hands, they only have 3 fingers, but you have 5. And so
Right.
what he's saying that the closer you can make every single move you make, because when you pour, like when you do this, there's an angle where your shoulder moves and where your the left shoulder moves, and there's an angle where your left foot goes. The more closely it is aligned with the exact bot, the quicker it'll pick up every single tiny little movements that you're doing that the bot then learns on its own, learns through your actions. So that's why
Yeah.
it's
I think
important to have 5 fingers. It's important to have, exactly the same wrist movement. And then, how Boston Dynamics has this disconjected joints. That
right.
actually, it looks cool, but it may not actually be as fast to train in everything you're
There's
thinking about,
Yeah, I mean, for better or worse, we've evolved in a certain way in human form,
Yep.
and there's certainly improvements that could be made to all our joints, actuators, if you will, and you could add that in at any point to something like Optimus, but you should start where there's real rich territory, which is just the easiest thing in the world is the easiest and hardest thing in the world is just to copy the human form.
Yeah.
And then to your point, it makes it learns that mimicked learning easier, um, and it makes interaction easier because every single thing in the world is built for the way we interact with it for the most part. And I suppose at some point, yes, you could add a finger or add something. I mean, I don't know. I'm not really too educated about this, but and get more out of it, and maybe something like that will happen. But actually, I don't think it will. I think it'll just get what the next couple like generation one Optimus will have limitations that we will understand when it arrives. I don't think, like, for example, with the iPhone, it was a lot of promise. It arrived, and we started feeling the limitations, and we knew, okay, when we got more memory, this would be available. This would be available, etc. We needed faster networks to really make this happen, larger screen sizes, etc. I think when Optimus arrives, we'll have that same kind of moment where we go, okay, this is what they did with their generation one release. Um, and we can immediately see the things that that it will probably need to do next. And I think in the next couple releases, it'll just really get closer and closer to all those little nuanced levels of human dexterity. And then beyond that, it can explode to places that humans don't play. But in the beginning, I think it's going to be about copying the human as precisely as possible.
And
Yeah.
when you think about it, they don't well, they want to go to consumer. Currently, they've not announced it, right? They basically said it's going to be used in the factory this year, one to
Right.
10,000 bots.
Right.
Then next year we'll start selling it to customers, and then uh, consumers. By the time it comes to us, if production design level 3, when that comes to us, it's going to be
Yeah.
so different than what it is now.
Yeah, and I think, and it's also possible that it'll be different in other ways to make it. It like factory based may have a certain different material structure to
Yeah.
do heavier lifting
Right.
than what than the home bot. So in a sense, there's a scale up in capability, but there's a scale
Yeah.
down for market to hit the market more horizontally to hit the consumer. And you see that in other products as well. But I think to a certain extent, while I believe that, I also think that um, Elon tries to keep product lines relatively simple.
Yep.
So I think the counter argument to that is that he may say, um, if it's a function of cost, then I see that happening. But if it's
Yeah.
not, he's probably going to just look at capability rising
I mean, I can
over
work
that
at a
curve,
factory
right?
and I can cook at
And I can,
home, and this is
right,
my form
exactly,
factor, right? So,
right, right.
yeah,
I can do barista during the day, and I can come home and do,
yeah,
yeah. I mean
you might,
that makes sense. But
but I do agree with you.
it
Yeah.
will be a
Well,
function
yeah,
of cost of materials,
yeah.
etc. And then how good they get at manufacturing a lot of them, because I think that's the big high quality problem that Tesla will have, and the reason that Tesla will succeed with this product. Not, there's a lot of reasons Tesla will succeed, Tesla
Mm.
specifically, and why did I title the article Tesla Optimus? Because actually,
Right.
is the next big thing. And to me, Tesla Optimus is the kind of the analog to the Apple's success and in the product lines that I put there, and not the IBM PC success or the Altair or the Commodore 64 or any of those kinds of products. Because when I look at the rest of what I see in robotics, they feel a lot like those products. And when I see
This is
the
a very big
Optimus,
point. Yeah.
yeah,
This is a
when I
very,
see
very, very good point. This is it.
Yeah.
This is the point, right? Why did you do Tesla Optimus as the next big thing, or
Right.
why that? It's the same thing with Steve Jobs. Like, why was the iPhone the thing? Because everybody will point out to you, hey, Android always comes out, already had that feature ahead of time, but it wasn't quite perfectly just, the way it is, that it didn't capture the audio consumers' imagination,
Right.
didn't get them to use it like 100% of the time.
Well, I mean, Android came to market after the
Android in
iPhone, right?
particular, but I mean,
Yeah.
afterwards, everybody kept saying, "Oh, they have this feature ahead of Android,
Right. Right.
iPhone,"
Right.
and then even before that, there were other phones, like you were pointing out, that already had a small screen, but not the full screen,
What
or they had the
it's
touch interface, but not the full thing, right?
there was a very large argument. I mean, this kind of harkens back to the original Apple II days, believe it or not. And there was a large argument at the time was the Apple II computer, and just around that time, they were building these for hobbyists,
Yeah.
and hobbyists wanted open systems with the most
Yep.
expandability, cards,
Yep.
all these things. And if you look at the Mac, which I
Yeah.
showed earlier,
Yeah.
it's largely a closed box. And
That was a
Steve
big
thought it,
debate. Yeah.
yeah, big debate. And Steve thought of it much differently. While he saw the hobbyists, I think he
Yeah.
rejected their story because he thought, okay, they'll get me going, but that's
Small
not where
market.
the
Yeah.
small market. And he saw this thing happen where if he could make an appliance, more of an appliance,
Hmm.
which led to the closed box with the Mac. And then, after he left Apple, the Mac 2 came out, which was an expandable Mac, which he probably wouldn't have done.
Hmm.
So, um, it's that story. And I think that Elon's very much like that. They're same characters in that regard, in that Elon's looking at this very, very clean design, mimic human form, very high end AI in terms of its interfacing to humans, its ability to learn, and keeping that designed clean without adding a bunch of the you know Boston Dynamics kind of features that are more
Hmm.
gimmicky or more hobbyist type of things. I mean,
Yeah.
isn't that the argument with the iPhone and Android to a certain extent? I mean, that people tell you, oh, see, on my iPhone, I mean, on my Android device, I could get root access and I could do this and I could do that, and of course,
Hmm.
0.1% do that.
Hmm.
It's not really, and if you focus your design on that side of the problem, you'll get it wrong. Whereas I think that's what Steve did, was he focused on what he knew the vast majority of consumers could use. And a lot of people attributed to him different motivations about a closed systems, about building
Right.
ecosystem, and
Yeah.
but you know one thing I always said about that is that they did that very purposely to make the experience amazing
Hmm.
and throw away. Steve used to have meetings with Johnny Ive, and one of the things that Johnny Ive would say to him, his designer, his main industrial designer, is, "I did this today, I did this today, I did this today," and Steve would say, "What did you get rid of?
Hmm.
What did you throw out?"
Yeah.
And it's a little bit like Elon's
Like what you
delete,
do.
delete, delete,
Delete,
right?
delete. Yep.
And what it is it's simplify the product so that most people can approach it and use it. And Steve was good at that, and Elon's good at that. Steve and Elon does it a little bit differently. His focus is, it's a lot more engineering focused in that regard, in terms of looking at the manufacturability of a product or the performance of a product. Um, but in a sense, it comes out the same way in the wash, right? It comes out the same way as this beautiful type of
Mm-hmm.
minimal design, maximum function product.
Yeah.
Um,
I mean,
you
I
know,
mean, again, just focusing on back on the hands, he delayed the product release. He made the hands arguably more complicated. If you
that's
saw
correct. Yeah,
like
yeah,
the
yeah.
32 different
Right.
like tendons going through, just are the
But
22
but
degrees of freedom. But it was like, in order to really get truly human capability, like threading a needle, playing a piano, And then, of course, using a drill, all those things, he needed
Well,
to
that's,
do
I mean,
this. And this is the
right.
difference. Yeah.
Yeah, you can't simplify to the point where you remove function that you consider
Right.
necessary. It's exactly the multi-touch, single touch argument, right?
Yeah.
Multi-touch is really complex in terms of how the software has to behave to make it happen,
Yeah.
but it has a simple, natural feel. So what did Elon do with Optimus? He's trying to make the hands as human as possible, so it
Mhm.
does all the things we talked about. And simple is hard from an engineering
There you
perspective. I
go.
mean, if you look at the latest, is it what is the engines used in the space? The Raptor engines, I believe, in the
Raptor
in
engines.
Star.
Yep.
Yeah, I
Yep.
mean, if you look at how each step, it's simplifying and removing parts. It's
Yep.
more
More
engineering
powerful.
work,
Yep.
more
More engines.
powerful,
Hmm.
more function, easier to build, easier to maintain. But the step up in engineering is there's no
Hmm.
easy in the engineering side of that. That's the hard part, right? And I think that's true of these products as well. To get that to really finesse the feature and make it the best it can be, it leans heavier on the engineering side.
Thank you
So
so much,
yeah,
Phil. I think you pointed out two very important things that many of us might have just not thought about. One is, yes, we're headed to humanoid bots, but this is a big step change. This is akin to the previous revolution step change that we've seen. And you explained why it's a brand new OS, brand new action that you can do it. And then why Tesla specifically, their Optimus is going to be not just like another humanoid bot. This is hitting the right
right,
mark, designed the right way, that's going to go mass market, that's going to go consumer, that's going to be able to do everything that a lot of the bots won't be able to do. Like this is just a completely different form. It's completely different than what anybody else can make at this point,
right.
right? They'll copy it, but they'll be so far behind. Yeah.
At the end of the day, I'll leave you with this thought: is that why I think that Tesla Optimus is the product and the successful product in this category
Hmm.
is because it feels so much like how Steve would build it,
Yeah.
and I have tremendous respect for both men.
Yep.
And I'm like, that's how Steve would do this. He would
Yeah.
probably lean in a bit more on the industrial design and kind of the user interface in terms of what you know there's a bit of an aspect here when you think of what Elon does, is it feels more engineering focused as a product, you know not as finessed as Steve might do it. But my point is that it's close enough to what Steve would build as a product and approach to the market, and that's why I compared it to the previous Apple products
Well,
and
that's
not
fair,
the
Phil. But
category, not the
yeah,
category.
no, that's fair. I mean, as I told you, I'm a huge Steve Jobs fan, but come on,
Hmm.
Elon Musk is another magnitude better than Steve.
Yeah,
He
yeah, yeah,
he
yeah.
he
But
launched an electric vehicle. Look at the Tesla car
right,
compared to
right, right.
other cars. It is just like the way Steve would have made it, even better in so many different ways. Like the car is
Yeah,
simplified. It's an Apple-like car, but even
yeah. No, no.
better. Like I'm telling you, it's like he surpassed Steve a long time ago in my
Yeah,
mind.
I
So,
think, but we have to see. We have to see that the playground that Steve was playing in as well. I mean, in other words, there was a lot. If you look at my kind of trajectory here, there's a lot of limits in technology that
hmm,
I mean, what would Steve be doing today at Apple? And remember, it's a very different thing here. Steve is not an engineer. Steve never wrote
exactly,
code.
exactly.
He didn't approach it that way. Um, but there are certain people um, that can have an intuitive grasp of things that they're not doing, and Steve was one of those people,
Yeah,
certainly. But I can't disagree with you at root level here. I would say that Elon's talents are just off the charts and much more capable in so many different ways. But um,
mhm.
but I think it's still a high degree of respect to say that Optimus will feel like a Steve product.
Agreed. I think it'll be the most successful product by far, even more than the iPhone has been.
Yeah.
Thank you so much, Phil. Appreciate
It's
you.
great.
Obviously, you come from Apple, you come from Rivian, and of course, you spend almost 24 hours of your day thinking about, talking about, understanding, and researching
I
Tesla.
do. I do.
You do, just like I do. Thank you, everybody. Follow Phil, by the way. Check out his other articles. They're just bangers all the time. Millions and millions of views. He's done one on FSD, explaining to you exactly how FSD works in a very simplistic, simple, but obviously very complicated, like deep way. He's obviously talked about Optimus several times, and of course, computing. Thanks, Phil. Check him out at PBEISEL. Thanks, everybody. Bye-bye.
All right.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.